Namaskar. I'm Priti and I welcome you all to our live and interactive session. You are watching us on PME Vidya, channel number 8 and also on our YouTube handle NCERT Official. This session is meant for the students of class 8 and the subject that we are taking up is science. The topic that we are going to learn today is nature of matter, elements, compounds and mixtures part 2. So, for this topic, if you have any queries, please feel free to get in touch with us. Our phone number is 8800440559. Our email ID is tth.class8@ciet.nic.in. And on our YouTube handle NCERT Official, you can send us your questions, suggestions and of course your feedback. For this session, we are joined by our expert, Ms. Priti Maan, who is TGT Science from Bharati Public School. Ma'am, namaskar and very warm welcome to you. And we both are accompanied by our Indian Sign Language interpreter, Mr. Dev Malik. Dev, namaskar and very warm welcome to you too. So, ma'am, since we are focusing on part 2 of this chapter, which means we have learned something in part 1 as well, so kindly give us a brief recap of the same.
Alright, so part 1 we discussed about the mixtures, how they are formed. They are formed when two or more substances are mixed together in any ratio. Then what are the different types of mixtures? It is homogeneous and heterogeneous. Homogeneous and heterogeneous mixtures, they are differentiated based on their composition. For homogeneous mixtures, the composition is uniform, and for heterogeneous mixture, the composition is non-uniform. Then we are seeing different examples of it. Like if we talk of homogeneous mixtures, salt dissolved in water.
Yeah.
So salt dissolved in water, we are not able to see where is salt.
Distinguish between,
yes. So solute and solvent, they are not able to get distinguished. But if sand is dissolved in water or oil is dissolved in water, we can very well see the layers, different layers or where the sand particles are present. So that's how we differentiated between these, and next we'll
learn today in part 2. And ma'am, since the topic says elements, compounds and mixtures, though we have already learnt about mixtures, now elements and compounds are generally get confused. Element, I think single entity, compound as the name says, it's something like two or more, a group basically. So what exactly these elements and compounds are, if we can get some examples and how they are found in nature, please tell us about that.
So we'll pick up that today. So these elements and compounds, they are called as what? The pure substances.
Okay.
Yes. So pure substances, like I said, what are they? That they cannot be separated into other kind of matter by any physical process. So we have certain examples of it, like salt, sugar, water, say gold. All of these are what? Pure substances, because they all are made up of single type of particle.
Okay.
Right. Now, if we pick up the example of salt here, so salt has all NaCl crystals present in it.
Yeah.
There's nothing that is mixed in it. Sugar has its formula C12H22O11. So all the particles are of that only. Right. Water, H2O. Yes, so all the particles are of H2O unless something is mixed into it. Now, if we talk of gold particles, that too 24 karat gold, because that's the purest form of gold that is present. So, in there, all particles are of gold only.
Yes.
Yes. So, according to scientists, when they say that something is pure, what does it mean that it contains only one type of particles? We have certain examples over here. So, see. This is magnesium ribbon.
Okay.
Okay. These are zinc.
Okay.
And this is iron in the powdered form.
Iron in the powdered form. Okay.
Yes, iron filings we call them as.
Okay.
And this is sulfur powder. So categorization, I'll make it easy for you. These three are metals and this is a non-metal. And they all are what? They are pure substances.
Yes.
Now, if we talk of any of these, right, iron, zinc, magnesium ribbon or sulfur, they contain all the particles of that very particular element.
Okay.
Yes. So iron, all iron elements, the same goes with zinc.
All zinc.
All magnesium, all sulfur. right? So they are classified as elements, and it's a pure substance.
Okay, so then if I want to ask for the definition of elements, what are elements?
So elements, again, they are what? They are the substances, right? They cannot be further broken down into simpler substances. Now coming back again to these examples that we have taken in over here. Now this is magnesium ribbon, right? If I even try to say
break it,
this will break because it is just malleable also and a thin.
Okay.
Right. So what will happen? Each time when I am breaking it, what exactly I am doing? I am just reducing the size of that magnesium ribbon.
The element and I would say the component in it remains the same.
Remains the same. It is made up of magnesium. So magnesium is there. It will not be breaking up something to something else.
Okay.
It is only dividing into smaller and smaller particle of it, like these iron fillings again. Right. All of us have seen iron rods. Yeah. Nails which are made up of irons. Now this is powdered form of iron,
yes.
Right. So what we have done in that, we have divided that say iron rod into these small pieces, and if we even pick up a single particle out of it, it will have the same formula as of Fe. Okay. So elements, they cannot be further broken down, right? If we even try to break it, we get the same formula as Fe only. Next examples we have seen, right? These all are the examples which are kept over here. Now each element is made up of identical particles which are called as atoms.
Okay, so ma'am, I want to ask you here, are elements always in solid state, because these are solid in nature?
Yes.
Or they're also liquid or gaseous in nature?
Okay, so for this we'll quickly explore our periodic table, because we have in our periodic table there are
elements,
118 elements which are present. They are present in their solid state, liquid state and gaseous state, right? So the picture of periodic table is there on the screen. If you just see it, it is the mini version of that, but that is how it looks like. We can refer to our book also.
It's Mendeleev's.
Yes, Mendeleev's periodic table we call it as, but later it was modified by Henry Moseley. So we take that periodic table into consideration.
Right.
Now if we see the periodic table right there, so right towards the left, which is pink and yellow, right, they all are metals and they are present in solid state. Towards right, we have all gases present.
You can use the cursor and you can let us know.
Yes. So this one, they all are solids, including some of the metals over here. Right here we have got all gases present, right, and there are certain liquids which are also present. So knowing the elements, will quickly see that what all sort of properties they are having. So first is, we have told that how many elements are present. It is 118. The table is completely full, right, and most of them they exist in solid state. Next one is 11 elements, they exist in gaseous states. Example we have of oxygen gas, nitrogen gas, helium, right. So if we talk of where they are placed, so helium is present here. Then we have oxygen which is present here and nitrogen present here in the periodic table.
Okay.
Next property if we see, or next information, that mercury, which is a metal, and bromine, they are present in their liquid state. So utility of mercury, we have also seen that it is filled in thermometers. Why it is done? So that any variation in the temperature, because metals are good conductor of heat.
But ma'am, is it the only metal that is present in liquid state?
So any variation is there in the temperature, you see the level of mercury rises in the thermometer,
up,
right? But now the thermometers are being made digitally, because the side effect of mercury is what? It is toxic in nature. So anyhow, if accidentally the thermometer breaks and it goes into the patient's body, so that is a toxic in nature. Next one, bromine, again that's present. It's a non-metal and it is present in its liquid state.
Okay.
Right. Now we have these two metals, gallium and cesium. They are present in their solid states. Okay, but they are liquid at the temperature around 30 degrees Celsius. So the moment temperature is rising up, okay, more than what is their normal room temperature, what will happen? They'll turn their states.
Okay.
So this is a bit of information of all the elements which are present in the periodic table.
Also, we learned that what exactly elements are, then they exist in different states. Now we also hear this one term very common when it comes to compounds, elements, that's molecules.
Right.
Like we say that water molecules are present there and here. So what exactly is a molecule and how is it formed? Is water a molecule? Like we have two elements there, hydrogen and oxygen.
Water is a molecule, very rightly said. Now we'll just see how are they formed.
Yes.
Or why molecule formation is taking place. See, all the elements which are there in our periodic table, they are not stable.
Okay.
If we talk of stability, the ones which are there at extreme right corner, they are the ones which are stable. Right. Now what do they do to achieve stability? Right. They react with some other element, and when they are reacting with some other element, what they do, they achieve stability. Like there's an equation given right in the slide, right at the top, H2 plus O2 giving H2O. Right. So in this, what do we see? Though we have these gases, H2 is a molecule in itself, O2 is a molecule in itself. When they are combining, they are forming H2O. Right. So simple, one more example we can take in here. Say NaCl only, Na and Cl.
Yes.
Right. So Na and Cl, common salt formula, we know,
yes, sodium
it is
chloride.
Sodium chloride. Now if we talk of their elemental state, so Na is not stable, Cl is also not stable.
Well, when you say they are not stable, what does that mean? It has something related to with the electrons?
Yes. So for sodium, it has got 11 electrons, right? It has 1 electron in its outermost shell, and that 1 electron it has to give to become stable. So we talk of octet rule, that element has to
have 8 electrons in the outermost shell.
Yes, 8 electrons in the outermost shell. So what exactly happen in here? It has this configuration.
Yes.
1 electron in the outermost shell, and this has 2, 8, 7.
Yeah.
So what happens? This gives 1 electron, this becomes 8, and here it takes 1 electron. But while this giving and taking take place, these atoms turn into their ions.
Okay.
So this becomes sodium ion and this become chloride ion. This acquires
so
positive
one which
charge.
is, sorry ma'am, I'm interrupting you. But there's something that I want to ask you. Use right plus and minus. So the one which is giving becomes positive.
The one which is receiving, giving electron, that means now which charge is more here?
Okay.
Positive charge is more. Because we say atoms are electrically neutral. They have same number of protons and electrons, right? So it has given 1 electron. There is a variation in the charges. So which charge is more in this? Positive charge is more. Okay. And it takes 1 electron. So which charge is more here? The negative charge is more. So we get NaCl, right? Now if we see in the formation of NaCl, if we talk of individual properties of Na and Cl, right? Na is a very reactive metal. It catches fire when it reacts with even moist air, because it readily loses electron. And Cl at the same time, it's a poisonous gas. But nobody dies of eating salt.
Yes.
Because when they are forming a molecule or when they are forming a compound, what exactly is happening? They are losing their properties, original properties, because a new substance is forming that has got completely different properties, right? So that's how it is mentioned here, that atoms of most of elements cannot exist independently. Why? Because they are not stable. 2 or more such atoms combine to form a stable particle of that element called a molecule. Like we have seen in case of water or in case of NaCl. Right? Now molecules further, they are divided into 2 categories, that is molecule of element and molecule of compound. Now molecule of elements are what? They are the molecules which are made up of same type of element. Like we write oxygen as O2, right? Then we write it is as Cl2, nitrogen gas as N2. These are what? These are stable. Only O is not stable, but that O, when it is combining with one more O, it forms oxygen gas. Now oxygen gas is capable of independent existence because that is stable. Now these three have same type of element. O2 has what? It is O and O. So that's called as what? Molecule of element.
Okay.
Now if we talk of H2O, now it has two elements present in it.
Yes.
Hydrogen and oxygen. So that's called as what? Molecule of a compound.
Okay, and that brings me to another question. What is compound?
Alright, so see, we have seen that elements, the smallest unit for elements are what? Atoms. Right? So when we even try to break off elements, what do we get? We get atoms. Same way, compounds, the smallest unit for compounds is what? Is a molecule.
Oh.
So this water molecules, when they are combining together, right, we get the whole lot of water. Now we have this salt here, copper sulfate. Now this has got the formula of CuSO4. Now if single crystal also, if I pick up from there, right, the smallest of crystal, that crystal will also be having the formula of what? CuSO4. So these many units of CuSO4 molecules are combining together to form this compound.
Okay.
Right? Now further we'll see. So example of NaCl is given here. We have seen that how are these two reacting. So while a compound formation takes place, what is important that the elements are always combining in fixed ratio. When we have prepared the mixtures, we were not worried about the fixed ratio, because say we can mix, while preparing the mixture, we can mix the constituent in any ratio.
Okay.
But when we are preparing compounds, for example, we are preparing H2O. So for preparing H2O, what is required? That we have two molecules of hydrogen gas reacting with one molecule of oxygen gas. That gives us two molecules of water, right?
Okay.
This is fixed. Like C plus O2 giving CO2, that is fixed, we cannot change it, right? So while forming a compound, what needs to be kept in consideration, that whatever is reacting, it is reacting in fixed ratio.
Okay.
We cannot change the composition as per our need. But while preparing the mixtures, we can do that.
Okay.
Okay. Next is that the properties of compound are different from those of elements forming that compound. Like I have talked of, Na has different properties, Cl has different properties, right? Both the properties are lethal.
Yes.
But when it is forming NaCl, the properties are completely getting
Different.
changed.
Okay.
Right? Next is what? Next point here is the constituent elements of a compound, they cannot be separated by any physical method.
For example?
For example, like if I talk of water, now I need to separate these two, H and O.
Yeah.
I cannot do that separation, say by sieving.
Yes.
I take a sieve and pour water, I will get hydrogen
No,
there
get
and
water.
oxygen. Same way for copper sulfate also, because this is also a compound, right? If I need to separate copper and sulfate out of these, I really need to do some chemical process.
Reaction, yeah.
Yes, then only they can be separated. Just like this, if I say that I'll hand pick copper out of it, that won't happen. That is possible in case of mixtures. Because the constituent, they are not exactly reacting together, they are just mixing together.
But also in mixtures, I think it's possible with the heterogeneous mixture. For
Yes.
homogeneous, we again need some kind of process to
Some
separate
kind
them.
of process is required. Right, so these are the properties of compounds, that how are they formed, what happens to the property of individual element when they are forming the compounds, and if we talk of separating them, so it's not easy. So
Right.
we really need to have some processes, with the help of that we can separate the constituent out.
So ma'am, I have figured out this thing, that when we are talking about compounds, we see two or more than two atoms coming together and forming one
Yes,
group.
yes.
And again, when you say mixture, you're still combining more than two or two, substances. So how these two are different basically?
Okay, we'll just see that now. So there is an activity given that how do we differentiate between mixtures and compounds. What we'll take is iron and sulfur. Now I'd shown it to you earlier also. This is sulfur powder and this is iron fillings.
Yeah.
Now this is a metal and this is what? A non-metal. Now we know the general properties of metals and non-metals. That metals, they are what? They are ductile, they are malleable
in nature.
They are good conductors of heat and electricity. Non-metals, they are non-malleable, non-ductile, they are not bad conductors of heat and electricity. They are the general physical properties. Now with the help of these two, right, colors we have seen that these are the colors, right. So for forming a mixture, what I'll do if I need to prepare a mixture out of these two, I'll just pick this up, small amount of iron and small amount of sulfur I'll take and I'll just mix it together. So this is what is a mixture.
Yeah.
I'm not considered about how much iron I have taken or how much sulfur I have taken. I've just mixed them together and I formed a mixture. When a compound is formed, right, so we need to heat it. So we are not heating, I'll just write down the equations so that it's clear that what exactly is happening when a compound formation is taking place. So we have iron here, right, we have sulfur. These two are reacting when we are heating it.
Okay.
Okay. On reaction, what is happening? It forms iron sulfide. Right, it forms FeS. Okay. So this is done when we have heated it, and overheating, what do we see exactly? That both the properties of iron and sulfur in here, it gets changed.
Okay.
So the FeS that is forming in here, it is of black color.
Okay. Okay.
Okay. So this is the compound that is getting formed. So I'll write here, this is for compound. So in this case, we have mixed them together. In this case, what we did, we reacted them. The ratio is fixed. We are taking 1 atom of iron that is reacting with 1 atom of sulfur and it is giving 1 molecule of iron sulfide. Right? Now we'll see how are they different in their properties. Now if you just look at the mixture, in mixture you can easily identify where are iron particles.
Yes.
Because the color is visible. The yellow particles are what? Sulfur, and the black particles are iron. So the composition, if we talk of this, so the composition is not uniform. But in this, when we obtain a black color iron sulfide, say suppose this is a crystal or this is iron sulfide, right? In this case, can you tell me where is iron and where is sulfur?
No.
No.
Everything
Because
is black.
a new substance is formed that has got completely different property and the composition is uniform.
Yeah.
Now, if we talk of separation, right? Now, we know iron is magnetic in nature. So, being magnetic, what will happen? It gets attracted towards the magnet.
Yeah.
So, if I just roll up, if I need to separate them out, what I'll do, I'll just roll magnet over this mixture, and what I see that all iron particles got separated. But same thing, if I do it on iron sulfide, what do you expect will happen? Will iron get attracted in this case?
Iron sulfide, no.
No. Why? Because now it is combined with sulfur. It is no more iron. This thing is combined with sulfur. So the properties
have changed. We learned that independent properties changed. Yes.
The properties got changed. So this is the mixture wherein the appearance is not changing. This is a compound wherein the same two elements, when they are reacting, they are just heated, they form a compound. Right? What we have seen, we can separate out the individual constituent using some methods like magnetic separation. In this case, that is not possible. There is one more reaction. We'll quickly see what happens when they react with acids. Okay. So iron, we know iron is a metal. Metal, when react with acid, it liberates hydrogen gas. At the same time, sulfur is a non-metal. Non-metals, they do not react with acids, right? So what exactly is happening? We'll quickly see those reactions also. Iron, when it reacts with HCl, it forms say FeCl2 and hydrogen gas is released. Now we know the properties of hydrogen gas, it is colorless and odorless gas. Same way, this was the compound that was formed. When this reacts with HCl, it forms FeCl2, but the gas formed is H2S. When these reactions are done in the lab, you know, when this gas is released, hydrogen sulfide gas, when it is released, the whole room, it has smell of rotten egg.
Oh.
Yes, so that's how they are different chemically also.
Yes.
Okay, so these were the points wherein how we can differentiate between mixtures and compounds.
And we also figure out when they react differently, then the output is totally different.
Yes.
And their original properties no more remain there. They become a total new compound, I would say. So that was all about elements, compounds, and of course mixtures. We also learned about some of the reactions taking place here. And this is, I think, one of the best ways to understand something, you know, keeping the practical and keeping the elements in place right in front.
This makes it clear. You know, you just take the
Yes.
names, atoms, elements, molecules, compounds. That doesn't give that much of clarity.
Yes. So, ma'am, like, is the chapter finished, or you
Yes,
will be coming
yes.
up with third part as well?
This is the
Okay,
end
so
of the
this is the
chapter.
final chapter containing 2 parts, and for both the parts I must thank my expert. Thank you so much, ma'am,
Thank you.
for your time and contribution. I would like to thank our ISL interpreter, Mr. Dev, also. Thank you so much, Dev, for accompanying us. And now, my dear viewers, very quickly let me tell you what's coming next. Here is the program schedule. So all our learners and viewers can now watch our next program, which will be on mathematics, and the topic is going to be power play. Well, with this, it's a wrap. This is me, Priti, signing off, and we'll join you soon. Namaskar.